Async Rust gives you massive performance, but there's a hidden problem most developers completely miss. Your tasks don't stop. They keep running in background even when your system is shutting down. And in production, this leads to memory leaks, stuck deployments, and unpredictable behavior. Today we are going to fix that by understanding task cancellation in Tokio the right way. So let's look at this example where we are spawning an infinite task. It can be anything in our production code, but for now we are just taking this example. So let's uh, see inside Tokio spawn we are looping infinite looping. Can be anything in our production. So let's run our program. As we can see, the spawn task is still running and it's never finishes because there's no automatic lifecycle management and no cancellation unless you implement it. Rust does not kill your tasks ever. This is just not theoretical. Real world issues also have Uh, servers don't shut down cleanly. Background workers keep consuming CPU. Database connections remain open. Memory slowly leaks over time. If you have ever seen a service hang during deployment, this is often the reason. And of course, using drop will not solve our problem. You might think dropping the handle cancels the task, but the task continues running in the background. As you can see in our terminal, the task is still running. So drop will not work here. This actually cancellation in Rust is cooperative. Also, task must check for cancellation, and task must decide to stop. Rust gives you control, but also responsibility. So the standard way to handle cancellation is using cancellation token from Tokio util. So let's implement Tokio util cancellation token. So for that we're going to import cancellation token from library, and then we'll generate our token cancellation new, and, and we'll create a child token also, or copy we can say. Then instead of running uh, our task alone, we'll apply cancellation like clone token cancellation here by using select. So what select is actually is, select macro is just nothing but it reacts to multiple events, and whoever completes the first, it will return that from future. So let's implement a cancellation with Tokyo select macro, and we are getting an error. Before say, okay, we have forgot to add move keyword. So yeah, now we exactly wait for 3 seconds to complete our task, and then we'll cancel our token. Also, let's await our handler. So we have successfully implemented Tokyo Util cancellation token, a task cancellation pattern. So now we're going to run our program and let's see. So as you can see, we have successfully implemented our first task cancellation pattern in Rust. At scale, this becomes a design pattern. Think of it like this: that Whenever you want to implement task cancellation, we can think in like task, there's a task trace, then parent-child cancellation, structure concurrency. Every task should have a life cycle. If a task can start, it must also be able to stop. So yeah, that's it for this video. Thank you.